Okay, the law of detachment is a form of deductive reasoning. In the law of detachment, it basically says that if you have a true statement, if P then Q, and you know that P is true, then Q is true. However, it does not work in reverse. You cannot say that if Q is true, P must be true. Even though sometimes that is the case, but you can't prove it.
Let's see if we can take a look at some conjectures and verify that they're true by using the law of detachment. So let's take a look and see. So in this first one, the following is given to be true. If M is the midpoint of a line segment, then M bisects the segment. And then we're also told that M is the midpoint of AB. And the question is it true? Can we prove the following conjecture that AM is congruent to MB? Well, a little picture here might be not a bad idea. So here's the line segment, AB. And M, we're told, is the midpoint. And then we also know that if M is the midpoint, then M bisects the segment. So M is the midpoint. Therefore, it bisects the segment. And so therefore, we know that this length equals that length. And so therefore, we know that, in fact, this segment is congruent to that segment. And so this is actually valid by the law of detachment. Because what we see here is we have this conditional statement. And then we're told that the hypothesis is true. So this is in some sense as if we're saying if P then Q, and then we're told that P is true, and by the law of detachment, that implies that Q is true. And so therefore the conclusion is that in fact we have two congruent pieces. Let's take a look at another example and see if we can verify a conjecture using the law of detachment. Here we go. So the statements that were given to be true are the following. If you are absent more than 2 times, then you will fail the class. And we're also told that Ed failed the class. The conjecture is Ed was absent more than 2 times. Can we use the law of detachment to actually prove the conjecture? Well, let's see. Remember, the law of detachment says that if P then Q, and you know that P is true, then you can conclude that Q is true. Now, is that logical template set up here? Well, here we have if P, that's if you're absent more than 2 times, so P is you're absent more than 2 times, then Q, you will fail the class. And we're told that Ed failed the class, so I'm told that Q is true. And I'm asked, well, Ed was absent more than twice, so this, in fact, is P. So I have if P then Q, and I'm told that Q is true. Can I conclude that P is true using the law of detachment? The answer is no. The law of detachment says if P then Q and P is true, then Q is true. Here we're given a logical statement where we have if P then Q and Q is true. We can't conclude anything about P using the law of detachment. So here we cannot prove the conjecture using the law of detachment. Neat.
The law of syllogism is another form of deductive reasoning. Remember, deductive reasoning is based on fact. The law of syllogism basically states that if you have a conditional statement where if P is true, then Q is true, and then you have a second conditional statement that uses this conclusion as the hypothesis, we call it Q again. So the second conditional statement says that if Q is true, then something else is true. We're going to use an or for the conclusion here. If P is true, then Q is true, and Q is true, then R is true, then you know that if P is true, R is true.
Let's take a look at some conjectures and see if we can verify them using the law of the syllogism. So the law of the syllogism is the one that says that if P implies Q, and if Q implies R, then P implies R. So let's take a look at this particular example here. See if I can put it up here for you to look at. So we're given the following to be true. So if the measure of angle A is bigger than 90 degrees but less than 180 degrees, then angle A is obtuse. So we're given that. We're also given the conditional statement that if angle A is obtuse, then it is not an acute angle. And given that is true, here's the conjecture. If the measure of angle A is bigger than 90 degrees but less than 180 degrees, then it is not an acute angle. Well, let's actually write out some of this and see if we can convert this to symbols. So let's let P be the statement that the measure of A is bigger than 90 degrees and less than 180 degrees. Then the first given is that P implies, and let's call Q, angle A is obtuse. So the first statement is P implies Q. What's the second conditional statement? Well, if A is obtuse, that's Q, remember, so that means that we're given that Q implies, then it is not an acute angle. Let's call not an acute angle that little statement R. So we're given that P implies Q, and we're given that Q implies R. And the question is, can we now conclude this? Well, what is that? Well, if the measure of A is greater than 90 degrees but less than 180, well, that's actually a P. Does that imply, this is the question, that the angle, therefore, is not an acute angle, which, of course, is the statement R? Well, the answer is yes. In fact, we can use the law of the syllogism because that's exactly what the law of the syllogism says. If P implies Q, and in turn Q implies R, then in fact we can put these two statements together and deduce that P implies R. So yes, we can use the law of the syllogism to actually verify this conjecture. Neat. Here, the given to be true is the following. If a number is a multiple of 10, then it is a multiple of 5. We also know the conditional statement that if the last digit of a number is 0, then it is a multiple of 5. The question is, can we use those two things and the law of the syllogism to prove the conjecture that if a number is a multiple of 10, then the last digit of the number is 0? Well, let's see if we can do this. So again, I'm going to see if I can convert these words to symbols. So a number is a multiple of 10. Let's call that P. And a number is a multiple of 5. Let's call that Q. So we have the first statement is P implies Q. Then the next statement is the last digit of a number is 0. Let's call that, that's a new statement, let's call that R. And that applies, then the number is a multiple of 5, and we've already called that Q. So those are the two things that we know. And the question is, can we conclude that if a number is a multiple of 10, that's P, can we conclude that the last digit of the number is 0, and that's statement R. So can we conclude that P implies R? Well, we can't conclude it by just using the law of the syllogism. No, because you see the law of the syllogism says that if you know that P implies Q and Q implies something else, then we can conclude that P implies the something else. But in this context, we can't do that. P implies Q, R implies Q, but we don't know anything about how P implies R. So we can't use the law of the syllogism to verify this. Maybe we can verify this in some other way, but not using the law of the syllogism, which is what we were asked. Neat. All right, let's take a look at a collection of statements and see what we can conclude using the laws of logic that we've developed so far. So here's a collection of statements. If Ed runs 10 miles on Monday, then he will not run the next day. We're also given that if Ed does not run on Tuesday, then he will run 10 miles on Wednesday. And finally, we're told that Ed ran 10 miles on Monday. Now, what can we conclude? Well, actually, if we write this out, we can make an interesting conclusion because we can apply the law of detachment. You see, the first statement says, if Ed runs 10 miles on Monday, then he will not run the next day. Well, we're given at the very end that Ed ran 10 miles on Monday. We know that's true. So by the law of detachment, if I think of this as if P then Q, then this last statement tells me that P is true. That implies that Q is true. So now I know that it's the case that he will not run 10 miles the next day. Well, the next day, of course, is Tuesday. So look at the next conditional statement. If Ed does not run on Tuesday, then he will run 10 miles on Wednesday. Well, we can actually apply the law of detachment yet again with this conditional statement. Since we've already concluded that he will not run on Tuesday, I can apply this statement to see that since he will not run on Tuesday, then we know he will run 10 miles on Wednesday. My conclusion, after using the law of detachment twice, is that Ed will run 10 miles on Wednesday, which sounds sort of daunting since I'm Ed. All right, how about this one? If a triangle is equilateral, then it has three 60-degree angles. We're given that. We're also given that if a triangle has three 60-degree angles, then it is not an obtuse triangle. And finally, we're given that triangle ABC is equilateral. Well, here again, we can actually use the law of detachment. We have if P, then Q, and we're told that P actually is true. The triangle is equilateral. Therefore, we can conclude by the law of detachment that Q is true. And so therefore, we see that triangle ABC has three 60-degree angles. Well, look at the next conditional statement. It says that if a triangle has three 60-degree angles, then it is not obtuse. Not an obtuse triangle. Since we know that this triangle ABC has three 60-degree angles, then we can actually apply the law of detachment yet again and make the conclusion that since this hypothesis is true, then this conclusion is true as well, and therefore we see that triangle ABC is not an obtuse triangle. So my conclusion from all this information is that triangle ABC is not an obtuse triangle. Using the law of detachment and using the law of the syllogism are important tools in order to provide a method to establish the truth of complicated, interesting, and important mathematical statements. Congratulations, and enjoy looking at these statements and establishing their validity for yourself.